this is Kevin Shaughnessy. So it says you're a cyber capability development lead, and I always love cyber capability because it's a great euphemism for a lot of things, but maybe you can go into detail as to what that means. But that's at SIXGEN, which I've heard a lot about. Anyways, Kevin, nice to see your face, and I'll let you take it from here.
All right. I'm Kevin Shaughnessy, and my talk today is going to be on malware doesn't have to be badware. So just a quick, who am I? I went to school for computer science, and I was a red team operator for about 6 years with different government organizations. While I was a red teamer, I dabbled in software development, but recently I kind of made the plunge to go full-time into offensive development. I am the cyber capability development lead at SIXGEN, which is a veteran-owned cybersecurity company based out of Annapolis, Maryland. They do a lot of good work there. So I'm going to be talking about C2 platforms. I'm not going to go into the technical nitty-gritty of how to make C2 work on every platform. This is more going to be about concepts. So first of all, what is a C2 platform? It is a collection of technology or software that allows an operator to get some level of control over a target. It is comprised of three main pieces: the agent, which is software that runs on the target, the communications platform or the communication protocols that agent uses to talk with the operator, and then the user interface that the operator actually uses to interface with the agent. So in this diagram, we have a very basic outlay of what a C2 platform could look like, with targets on the bottom talking to command and control servers, and then the operator talking to those command and control servers. So you'll notice that the bottom is in red and the top is in green. So that's to signify that the external networks, the target networks, are hostile. You're subject to potential investigation, people trying to block your access, or even just changes in the environment that you have no control over. And then on the green side, you have your internal infrastructure that you have control over. You're not worried about your antivirus. You're not worried about people snooping the data. And there's a lot of different ways you can architect it. But in this example, we're using those servers as kind of the barrier between the hostile world and your own internal stuff. So why does this matter? Why do you care about having well-designed C2? So there's two main goals of having a C2 platform. You can design it for either red teaming or CNO needs. As a red teamer, your job is to give net defenders a very realistic experience for what a real threat actor could look like. You're going beyond just contrived scenarios or small segments of activity to giving them the real deal without the potential for them being really compromised. And in order to do that, you have to have tools that are on par with what real bad guys are using. So you need to have good tools. And on the other side of that, with cyber being increasingly important in our day-to-day lives, and our national security needs, CNO guys that are fighting for the good side need to have good software. That's just, there's no getting around it. So I've identified three kind of overarching design goals for a CNO platform: flexibility, resilience, and safety. And these three things have some interplay with each other. And we'll go over how they apply to each individual part of the platform. So we're really going to nail that here. So flexibility. What we're talking about with flexibility as it applies to C2 platforms are, do you force operators to operate a certain way? So are you enforcing specific TTPs or tools, tactics, and procedures? For instance, let's say you have a tool that when it runs, it starts up notepad.exe and injects itself into that process. So that's great. You're attempting to hide your behavior, but at the same time, if you're operating in an environment where that isn't either allowed or maybe it gets caught, your tool is now completely unusable. And you have to go back to the drawing board, redevelop, spend time, spend money, and then give your operators something else to use. At the same time, we have to make it so that operators are able to easily use your platform in a multitude of environments. In the real world, you could be going up against old platforms, bleeding edge new platforms. You could be going against environments with very slow internet speeds, for instance. So you just have to make sure you build in some tolerances. So resiliency, it's similar to flexibility, but this is being applied more on the end of if I have part of my platform caught, how bad is that going to be? So I'm really going to hammer on the idea of being burned or being caught. So part of your platform has been identified as malicious. It's been signatured, whether that's the agent or part of the C2 protocols that you're using. But it means that your tool is no longer usable in the environment, and you have to do some kind of new development to make it usable again. If you get burned in one environment, it's also highly likely that those signatures get passed around to different antivirus vendors, different security companies. So if you get burned in one place, it's likely you'll get burned in more places. So it's just figuring out how to segment your tooling and make it so it's resilient to those kinds of effects. And for safety, so this is more about, are you causing unintended effects on the target platform? Are you accidentally deleting files? Are you causing system crashes? Are you leaking data through your C2 that could be snooped and potentially used negatively? So first, we're going to talk about the agent. What is an agent? It's software that runs on the target and provides some level of command and control to the operator. It can be written in any language. It can be any kind of file, as long as it provides some kind of code execution, and like I said, some form of control. Now, a well-designed agent will be hard to distinguish from legitimate software because you're deploying it in a hostile environment where people are actively looking for malicious activity and tools that will enable malicious activity. So how does flexibility apply to an agent? We're going to talk about staging, which is moving your level of functionality either up or down on a target. We're going to talk about modularity, which is a similar concept, but it applies to a single agent. And we're going to talk about dynamic code execution, which is if you've heard of Cobalt Strike's beacon object files, it's going to be in that vein. So staging. How do I go from initial access to my full capability? Well, the way I've identified it, there's basically 3 stages. You have your loader, your limited stage, and then your full capability. So your loader is going to be used as your initial access vector. It could be a remote code execution payload. It could be a phishing payload. Its entire job is to be disposable and to get your limited functionality stager into memory. The reason you want to segment like this is because initial access is the most dangerous part of the operation. It's the time you're most likely to be burned. It's the time you're most likely to have your payloads analyzed. And if you throw your full capability during that stage of the operation, it's very likely that you're going to have to, again, go back to the drawing board, spend a lot of time, a lot of money to re-implement that functionality. And then we go to the more limited capability agent. So this is going to be loading shellcode in memory, maybe doing a few file operations, but nothing too major. So it's again about limiting the exposure of your full capability. You can use this for putting persistence down on file. If it gets caught, then again, it's not as damaging, it's not as expensive as if your full capability is caught. And then you can use it to move up to the full capability. Recommend that this is only in memory, that you only use it after you've determined that the target you're on is both a valid target for your operation, whatever that means to your mission, that it is suitable in terms of what kind of defenses it has. If you know that your full agent isn't capable of withstanding whatever security product is on that machine, then you don't have to deploy it, and you shouldn't deploy it. You can also use these different stages to have different modes of C2 to differentiate your operations, so that if, say, your stage 1 gets caught, but your stage 2 is doing completely different things, then you don't have to worry about burning everything all in one go. Talking about modularity, aka how to have small payloads with big features. So for an agent design, a lot of times what you want to do is have the core implant. So you have a small bit of code that does a few things, maybe some file operations and module loading. So a module is going to be a compiled, self-contained container of functionality, essentially. On Windows, a lot of times it's a DLL. On Linux, it could be a shared object file. But essentially what happens is you send this module over the net, and then your agent loads it into its own memory space and has access to those functions. The reason you want to do this is similar to the reason you want to use staging. It gives you a small payload to initially put on the machine, and if your core implant is compromised, you don't have to worry about retooling every single capability that you've implemented. There's two main schools of thought you can use for module implementation, persistent versus temporary. Persistent, you're loading the module into memory, and you're keeping it there every time those features need to be accessed by an operator. So this limits the amount of times that you're uploading a module. It limits the amount of times that you're loading more memory. But it also means that if anyone performs memory analysis on your agent, those capabilities are going to be there with it. So just a little more exposure. On the temporary side, you can allocate that memory, use the function, and then deallocate it. So every time you want to use it, you have to re-upload it. But it also gives you a little more peace of mind that if someone catches your agent memory, they don't have all of that functionality in one spot. Dynamic code execution. So how is it different from modules? So a module, like I said, is a precompiled, it's bigger, and it's usually C2 platform dependent. Whereas for dynamic code execution, like beacon object files, it's relatively platform independent. It allows operators to just either write up some quick C code or use like something off GitHub that's been vetted. And it just gives them a lot more flexibility to do what they need to do without coming to the developer and saying, hey, we need you to implement this function right now. Resiliency. So resiliency applies to the agent. If someone identifies your agent, how much information can they get from it? Or at the same time, how likely are they to be able to identify it as being malicious in the first place? So a couple of common techniques to implement this are binary stripping. So you're taking out all the debug information from the binary. And this does two things. It limits the size, and it gives reverse engineers a lot less information when they're trying to analyze your binary. So as you can see here, I have a test binary on the left and a stripped binary on the right. It's the same executable, just one has used GNU strip on it. It's just a C program that literally prints hi. And you can see on the bottom that you have a space savings of 4 kilobytes for just that very simple program. So you get a lot of benefit from doing binary stripping. There's also string obfuscation. So in your implant, you're probably going to have strings for like URLs that you're using for C2, strings for command names, things like that. Things that can either give more information about your operation or be used to create static signatures for the agent. And a quick way to get around that is to just do some kind of reversible encoding or static key encryption of the strings, so that even though the strings will still be there, it's not identifiable what they are, how they're used, etc. You can also use encryption. You can either have like a loader where the shellcode is encrypted, and then the loader decrypts it and throws it in memory. You can use a packer or crypter program similar to UPX, if you've heard of it. It's the most common one out there. And it will encrypt your executable and put a stub that decrypts it when it's run. There's also environmental keying. So this is if you're getting real fancy and you already have some previous information about your target. So you already know like an IP address or host name, something uniquely identifiable. And what this will do is it'll look for that information, and if it's on any other host, it won't run. So this is really useful for things like code sandboxes, where reverse engineering tools will put automatic sandbox environments with random names, random IPs, and try to run whatever the agent is. So this is a way of getting around that. For safety, you need to make sure that all of your code has some kind of error handling and exception handling. If you don't, then you are always inviting the possibility for crashes. And if you're, say, injected into a process and your agent crashes, then that process is also crashing. And it could be something relatively benign, like a notepad, for instance, or it could be a system process. And if that system process crashes and the machine blue screens, then you have the potential of the user calling up IT like, hey, my machine's blue screening, I don't know what's going on. And you have an investigation on the box, which is something you really want to avoid. And then the concept of clean exiting, or when you're done with the machine, making sure you clean off all of your artifacts, try to remove as much of the memory that you've allocated as possible, just trying to restore the machine to a pristine state as if you were never there. Next, we're going to talk about communication. So the way that the agent and the operator interact with each other. The ways you can implement C2 are infinite. You're really limited only by your creativity. That's why I have that little diagram there, how C2 design occupies the space between art and science. As long as it's a valid way for two machines to talk to each other, you can use it. You can use anything from Twitter messages, Google Docs, writing it to a document, just straight up DNS, HTTPS. The world's your oyster. Communications can be broken down into internal versus external. So external communications are going to be target talking directly to the C2 server, or bouncing through a redirector server and then talking to the C2 server. But it's going to be data leaving the target environment. Internal communications are peer-to-peer. So your agent talking to another agent somewhere else in the network. This is important because there are going to be machines that either aren't allowed to talk out through some firewall rule, or if they do talk out, then you're going to invite some security investigations. So flexibility of communications. You need to have multiple protocols available. If one protocol gets burned and that's all you have, and now you can't talk to your agent, you're dead in the water. Like your mission is no longer able to be prosecuted, and you now have stranded tools that are just waiting to be found. So it's best to have at least two, more if you can. So HTTPS and then DNS if HTTPS doesn't work, or a combination of HTTPS and TCP. You need to give your operators options, and you need to be able to customize on the fly. So what I mean by that is, say you have HTTP. That's a protocol that has numerous options in the way that it's presented. You can use different HTTP verbs. You can use different header fields. And the more options you give your operator to change that, the more that they can vary up the look of the C2. So they're not as at risk for static identification. Resiliency as it applies to communications, you have to think about latency. So you could be operating in a network that has dial-up level connectivity. It could be super slow. And if your server isn't able to handle that amount of delay, then you could potentially lose access just for that reason. You could potentially have an operation with large numbers of agents. Maybe you're compromising large amounts of computers. And again, you need to be able to handle that. For large data transfers, there's a couple of ways of looking at it. So you can either handle large data transfers by making sure you're capable of handling the bandwidth of, a few gigs of data, or making sure that your C2 is capable of splitting up data. So instead of downloading 4 gigabytes at one time, maybe you want to do it, a megabyte at a time, and then wait 5 minutes. But either way, you need to be capable of handling it one way or the other. You also need to be capable of defeating what I call the eyeball test. So if an analyst is watching Wireshark and they see your C2 go across the wire, are they going to immediately pick it out as, hey, that's really weird, we need to look into it? Or does it blend in with all the other web traffic and no one really thinks anything of it? Safety as it applies to comms, mostly focusing on data encryption and attribution. So for data encryption, if you're using, say, HTTP with plain text data, then anyone who snoops on your traffic is going to be able to see that. An instance where that could be really bad. If you're a red teamer and you're operating on a hospital network, for instance, and HIPAA data is being leaked, you're going to have a bad day, and so are a lot of other people. But if you're encrypting that data with AES or RC4, and hopefully another protocol on top of it, if you can, like HTTPS, then it's going to be a lot safer for everyone, and you're not going to be potentially endangering your customer. In terms of attribution, so we have 2 diagrams here. The top one, the target is talking directly to your C2 server, and it's just out in the open. That is not great, because if they identify the IP of the team server, if they are able to block access to it just off the bat, then you're done. Like there's not anything you can do about that. So please don't do that. But if you have multiple, what we call redirectors, which are servers that exist as a misdirection, if you will, between your target and your C2 server, then you can just migrate from one C2 server to another. You can implement some kind of round robin so that if your agent isn't able to talk to example.com, it then moves to a C2 using Twitter DMs, so that you still maintain access, and then keeping your C2 server behind a firewall so that only the traffic you truly want gets to it will make it a lot easier to maintain the integrity of the team server, so that you make sure no other actors are interfering with it, and also that it's not as easily identified by security vendors. So the user interface, I'm not going to go into as much detail about, because there are just so many things you can talk about. There's so many options for it. But kind of broad strokes, you can either be command-based or graphic-based. Doesn't matter, as long as it's intuitive for the operator to use. That's really all that matters in that respect. And you can create a paradigm of either interactive or non-interactive use. So an interactive would be, an operator has a terminal essentially with the agent. They can put commands in and immediately get responses. Or the non-interactive, where the operator puts a command in and isn't expecting a response until maybe a couple hours later. And that influences the way that you design the interface, how operators view the data. Flexibility as it applies to the UI. Can operators change how data is presented? And that kind of falls into automation. So in Cobalt Strike, for instance, there are aggressor scripts you can use to change and enrich the data. So you can make certain things pop out with color. You can change the columns of information. And it also allows you to do automated tasking. So you can, as an operator, let's say every time a new machine comes in, you always run the same 5 commands. Now, if you're having to type those 5 commands over and over as new machines come in, or maybe a machine comes in, you don't see it for a couple hours, then you have to put it in then. It takes time and it's not very efficient. But if you have some way to automate that, so an operator can create like a quick little script, I want these 5 commands run on every new machine that comes in, it's going to make life a lot easier for them, and they're going to like you a lot more. So resiliency. Again, error handling. The reason I bring this up for the UI, even though it's in that green space of, you're not worried about the vendors, you're not worried about your operation coming to a halt, you're still at the point where you're putting user input. Anytime you handle user input, the odds of something going wrong are astronomically higher. And if your client crashes and the operator can no longer talk to an agent, then you have an agent that's just sitting there with no way to clean it off, no way to give it tasking. That's kind of a worst case scenario. So you need to make sure that every option you give the operators, that it's thoroughly vetted, that their user input is sanitized or otherwise handled appropriately. And you need to make sure that your client can scale with your operations. So if you have a big team of, say, 50 people, and you're doing multiple operations at once, you're handling 100 computers, your client needs to be able to show data for all those computers. It needs to be able to handle synchronous operations between all of those operators. So this is something you need to keep in mind when you're designing a C2 platform. And then safety. So are the logs or data being securely stored? When you're using a C2 platform, generally you're collecting sensitive data. You're collecting password hashes. You're collecting potentially key logs, screenshots. You're pulling down sensitive files. So in order to maintain the integrity of that and to make sure that unauthorized persons aren't able to see it, you should really store it in an encrypted way, or somehow to require like a password to look at that data. You should consider user authentication in your client. So that limits people that maybe exist in the space that you're operating out of but aren't authorized to use the implant or aren't authorized to see the data. It just makes sure that there's no unintended actions and that all actions are properly assigned to a person. So there's nothing that happens and someone says, hey, who did this? I don't know. And something else to consider are potential user roles. So if you have an operator that's very new to the team, do you want to give them access to everything? Do you want them to be able to perform all actions? Or do you want to segregate it so that you have certain levels of access and certain levels of ability to perform actions? So just to recap, we went over the C2 platform, which consists of the agent, communications, and the user interface. And then we went over design principles of flexibility, resilience, and safety for each of those components. Thank you for your time. That concludes my presentation.
Let me unmute myself. Cool, thank you. Does anyone have any questions? Please drop that in the Discord. And I've got a few myself, if you don't mind, Kevin.
Oh, yeah, of course.
Yeah, so I kind of took notes throughout the talk, so forgive me for going back to the beginning. But you mentioned modularity. And every time I've had to think about modularity, it inevitably ends with configuration management, because you got a lot of components that you're sticking together and something will go wrong and you got to figure out what all you put on the box. And then that just gets even more wild when you add in binary diversity. How have you tried solving configuration management, I guess, is the question.
So when you say configuration management, you mean making sure that modules for a specific implant go to that platform. You're not actually sending those modules to a different one, or?
Yeah, or like this is what we put on the box, and either now we have to figure out what went wrong, or now we have to clean it all up. So we got to make sure each component is there. But then you also have like versions, right? So if you've got a module and you update your module, do you uninstall and reinstall all your modules, or do you just track, each operation, what you're laying down on the box? I was just curious if you thought about that problem, because it's been a difficult one. It's never been something that any shop does the same way.
Gotcha. Yeah, I can't say it's something that I've deeply considered for this, but
Sure.
that does sound like a very tricky problem to solve.
Yeah, I mean, there's been some really cool advancements in just like reproducible builds in general. Like one of them, I think it was working with Clang to embed checksums of each source file that was used to produce the binary, so that you can somehow like walk back from the binary to whatever project was used to produce it. And so you can get probably some approximation of whatever version it was if you're not also embedding that in the binary. But I feel like that might be a bit much, like especially if you're worried about binary size. I can imagine checksums would add up pretty quickly for a lot of the projects that I've had to build. But I don't know. It's a cool problem area that I haven't really done a whole lot with, but I was curious if you had any thoughts about it. Have you ever looked at a stripped Rust binary?
No, I haven't.
It's wonderful. Oh my goodness, it is beautiful. I'll actually, so it's actually part of the compiler now, or specifically Cargo, I think, where you can just put in a setting and it'll strip your binaries for you. And it makes it substantially smaller. Like Rust includes quite a bit with their release builds if you don't do this otherwise. But like just the default optimizations, every single for loop, conditional, anything just becomes a function. And I think they're all vectored too. So, or not vectored, virtual tabled. But anyways, just that one single option that you put in your cargo.toml, and just your whole binary just becomes a mess to look at in a I was looking at it in Binja. I have no idea if Ghidra or IdaPro would have better luck with that. There might be some pretty good plugins, but I haven't gotten any of them working.
I'll have to play with that. Yeah, that sounds really cool.
Yeah. See if there's all right, I'm not seeing any more questions. So I do have one last one, but it's kind of a generic, like, have you ever had an operator request a non-interactive UI? Because I've gotten so much pushback on that, where it's like, no, you don't really need a command line, but they want it.
I actually have had a few people that want to have that really long polling, and to make sure that other operators don't have the option to shorten it.
Yeah.
So it's pretty niche, but yeah, I actually have had that requested.
Nice.
Well, thanks so much, Kevin. We really appreciate your time. And folks that are listening, the next one will start at 1:15, where we'll have Sid Malware talking about dissecting Agent Tesla for us. So if you want to go grab a snack, coffee, lunch, whatever you got, we'll see you back in about 12 minutes. Kevin, thank you again so very much. We really appreciate this.
Thank you guys for having me. This was a lot of fun.
Yeah, no problem.